Hello and welcome to today's episode. Today we are taking a look at GitOps and the GitOps Toolkit. And who better to join me than Stefan? Hey Stefan, how are you? Oh, I can't hear you.
Okay, sorry.
Fear there. I was like, oh shit, what's happened? There we can hear you. How are you, Stefan?
Great. Very happy to be here and share the work we've been doing on the GitOps Toolkit and the road to Flux V2.
Awesome. Well, I think the best thing for us to do would best be to quickly give an overview of what GitOps is.
Right. So GitOps is a way of doing operations through a Git repo. You define your state there and it's happening by magic on your Kubernetes clusters. That's
Excellent.
the gist.
So we store our declarative state in a Git repository and it is magically applied to our clusters for us. And to do that, we need tooling. And you've got quite a lot of experience in providing the tooling that actually makes this work. So I guess sorry, on you go.
Yeah, we started, I think, 4 years ago with Flux as a way to run a daemon on the cluster that can be configured. You tell the daemon, hey, there is my Git repo, here is the authentication for it. Whatever you find in there, try and reconcile that particular state on the cluster and follow any other change. And also, do garbage collection. If someone deletes something from Git, you also delete it from the cluster. So it's more about, it's like a proxy between your Git changes and what's happening inside the cluster without you having to directly connect to the cluster and perform those changes manually from your laptop.
Excellent. So, like you said, there, you've been working on Flux for a number of years now. And we're now at a stage where there's the GitOps Toolkit and conversations around Flux V2. Can you maybe just explain what the GitOps Toolkit is and where Flux V2 kind of comes into the picture as well?
Yeah, so the toolkit, like the name implies, is a collection of tools. Flux version 1 was this monolith that you deploy and does a bunch of things for you. So we took Flux apart, we break it down into microservices, and we then will be assembling back Flux from this microservice. And these microservices are Kubernetes controllers built with KubeBuilder, and the configuration part of your whole GitOps pipeline is made through Kubernetes custom resources, unlike Flux v1, which you would configure it with in your deployment spec with command flags for Flux. So it gives you more, freedom to do a bunch of stuff.
Okay, what is the status of GitOps Toolkit? I think there's been a fair number of releases over the last week. The last time we spoke, you mentioned the API was stabilizing. I mean, is it in a position where people should now start to pick GitOps Toolkit over Flux v1, or should they wait a little bit longer?
So we've started with the toolkit experimental things around 6 or 7 months ago, and we've published a roadmap on the website. We broke the roadmap into 3 milestones. One milestone is get on feature parity with Helm operator. Helm operator is the component that deals with Helm in a creative way, and for the Helm features, we are at 100% feature parity in the GitOps Toolkit. So for people that are using today Helm operator, they could switch to the toolkit and have the same features there and many other features on top of that. Regarding to Flux, we split Flux into 2 milestones. One is Flux in read-only mode. What that means is where Flux connects to a Git repo with a read-only deploy key. So it will not commit back, it will not write anything to Git. It looks at Git and applies it. And for this milestone, we are in future parity in the toolkit, so you can use it today to synchronize your Git repos. And Flux has a feature where it can scan container registries, find new image tags that you've pushed there, and write those back to your Git repo based on some policies, for example, I don't know, semver range or git sha and so on. And that particular feature is still under development. So if you are using Flux today and you are relying on the write back mechanism, the image update mechanism, you'll have to wait more, probably till the end of the year when we get that out. For the Helm operations and Git synchronization, the current toolkit API is no longer alpha. We've published the V1 beta 1 release last week, and yeah, I'm thinking it's ready to go for sure.
Excellent. Well, I'm very excited for today. I'm also not the only one. We have a comment from Ilya who says he's very excited about Flux v2 and the GitOps Toolkit. So we're all we're all really happy. We're looking to see this. We all want to start using it. So let's just share my screen, walk through the process of how people can start to use the GitOps Toolkit today.
Cool.
All right. So, boom, there we go. So I've gone ahead and configured as little as possible up front. Of course, we need a Kubernetes cluster. So I spun up one using the cluster API on Equinix Metal, and it is good to go. Let's run get nodes, make sure I haven't broken anything in the last 5 minutes. Excellent. Now, we have a couple of resources. You've very kindly provided this guest, which I will share in the YouTube show notes when the episode is finished. So this is a rough kind of playbook of the things we're going to cover today. And at your recommendation, I have also configured a GitHub organization that we're going to try and use for today's examples. So do you want to just explain, the first thing I see here is the first command we have to do is GOTK bootstrap and then a whole bunch of parameters. What is this command going to do to my cluster?
So the toolkit is composed out of a CLI that you can use to install, to bootstrap, to configure, to debug what's happening on your cluster, and a bunch of controllers, each with its own scope. For example, we have a controller that deals with sources like Git repositories or Helm repositories or even S3 buckets. So you can add sources, remove sources, and so on. And there are other controllers as well. The bootstrap command, what it does, it takes an owner, let's say a GitHub organization. You pass it a GitHub organization and a repository name, and it creates that repository for you. If you have, let's say, teams inside your GitHub org, you can also tell it which teams should have access to this repo. The repo is created by default private. You can also create the repo public. And what's happening there, the CLI will create the repo, will push to the repo the toolkit definition, like the deployments, the custom resource definitions, and so on, applies them on the cluster, then it configures this particular repository to be the source of truth for your cluster. And what that means, it creates a deploy key, it sets up the deploy key in your GitHub repo, and then it starts to listen to whatever is happening on your main branch. So every time you do a commit there, you change something, even the toolkit definitions itself. So if you, let's say, run the bootstrap command once, then in a couple of weeks, you run it again, it will not create a new repo. It will see, okay, the repo is there, but maybe the toolkit components have advanced to a new version. It will do an upgrade. And how it does the upgrade, it just modifies the YAML inside your repo, and the toolkit itself upgrades it. It upgrades itself on the cluster.
Very cool.
That's about it.
All right, so let's just grab this command then. And I just need to make a few changes. So my organization is rockcode does GitOps. And I can just give this any name, and this is going to be created for me, right?
Yeah.
I did go ahead and create a team dev, so maybe we can talk about that feature in a moment. And then the path, I'm assuming, is where it's going to store the manifest in a repository.
Yeah, so the repository created by Bootstrap is meant to be used for your whole fleet of clusters, not just one. So you can, using the path, you say, hey, this particular instance is for that path, and you can use the cluster name for it. One use case for that is you may want to test the toolkit upgrade on your staging cluster before upgrading your production cluster and so on. So the definitions are stored for each cluster separately.
Okay, well, I like to live life on the edge, so we'll call this my production cluster. And returned. Oh, I got bad credentials already. So
bad credentials. So you need the GitHub _token environment variable set before you can.
I will quickly move that off screen and check. GitHub _token, right?
Yeah.
It's got a space in it. All right, let's fix that. So I wouldn't have thought that would have caused a problem. Put loads of text on my screen so that when I move it back, yep, we don't reveal my token. All right, I'm going to try that again. There we go. So yeah, we've got repository created. It had, it's away with the world now. Okay, it's created. Oh no, it's granted access to the dev team, cloned the repository, generating some manifests, and then provisioning itself within the cluster. It's doing a lot for me. I don't really need to do anything, right? It just.
Yeah, with Flux, we've seen people struggling with the configuration. So we said, okay, let's use the GitHub and GitLab APIs so we can streamline the whole process with a single command. We are looking at, I don't know, people that have experience with Bitbucket. If you know Bitbucket, if you are using it and you are familiar with Go, yeah, we are looking for someone to help us add the Bitbucket implementation to the Bootstrap command. Now, maybe you are not running on any of those SaaS Git providers, so we also have instructions on how you can do the whole thing manually. You create the Git repo on your own, then you generate the manifest, you push them, and you set up the deploy key. But yeah, the Bootstrap command also does a sanity check of what's installed. So it checked all the controllers. If you do, for example, kubectl -n GOTK system, get pods, we'll see we have 4 controllers here. So the source controller is the one that pulls data from Git, Helm repositories, S3 buckets, and so on. The notification controller is a daemon that can listen to webhooks from GitHub or GitLab or Jenkins or whatever. So you can trigger instant reconciliation inside your cluster. It also pushes notifications from your cluster to, let's say, Slack, Microsoft Teams, Rocket, and other chat systems. The customized controller, it's a controller that can work with customizations or with plain YAMLs. So it applies that on your cluster, does garbage collection for you, health checking, and all sorts of things. And Helm controller does the same stuff, but for health charts. And that's the toolkit.
Awesome. So we've got 4 controllers. The notification controller immediately is kind of interesting to me. So it can push notifications to say that it's updated something within the cluster. That was one aspect of it. The other part was it can listen for webhooks coming from GitHub, GitLab, etc. So does it configure any of those webhooks for me to push to my cluster, or is that something that I need to go in and manually set up?
So there are a couple of custom resources which you can use to configure things. One custom resource is called the receiver. So you can create a receiver of type GitHub, and it will generate a unique URL that you can use in your GitHub webhooks. And it also gives you a secret to check that GitHub is really sending all those notifications. For GitLab the same, and so on. So that's the receiver part, when you can define this kind of receivers, and you can suspend them, you can delete them, and so on. And you can also create alerts for different providers. You can add, for example, your Slack channel there with API token. Then you create an alert and say, hey, if my contour Helm release is failing, post the error message to this Slack channel, and so on. So there are custom resources which you can define receivers and alerts.
Okay, perfect. So if we take a look at my organization here, I'm curious about what's happened on the GitHub side of this API then. Yeah. So we have this new repository here. Okay, so it's created a directory with the path that we provided. And this is the YAML for deploying itself.
Yeah.
Okay.
So if we look at the toolkit source.yaml,
yep.
Can you make that bigger?
I can.
Yeah. So this is how a source gets added on the cluster. You give it the URL. In this case, is an SSH. It created already a secret that contains the SSH public and private and known host keys. And using that particular secret, now it monitors the main branch of that URL.
Okay. So every 1 minute, it's going to check for changes to this repository and then just apply them to my cluster.
This particular object only pulls the
okay.
repo on the cluster. There is a different object, customization. And the customization object says, hey, from this source, name GOTK system, apply the production path on the cluster. And prune true means if you delete something from inside the production directory, it will also be deleted from the cluster. So this enables garbage collection, and this is applied every 10 minutes.
Okay, so let me clarify those two intervals then. Our GitRepository CRD is pulling changes every 1 minute, but the actual application of those changes is on a 10-minute schedule. Does that just mean that if I push something to the cluster multiple times before the 10-minute starts, those all get applied at once?
No.
No.
So this interval here for the customization, 10 minutes, what it does, it applies what is found in the repo at that particular path every 10 minutes. What that means is, let's say someone goes into the cluster, has access to the cluster, modifies something. In a maximum of 10 minutes, that modification will be undone. If it modifies something in the toolkit itself, let's say it configures, it changes the limits, those kind of changes will be undone. But if you push something to the repo, in 1 minute, the source controller will detect that there is a change, and through a Kubernetes event, it notifies the customized controller, hey, there is a change. Don't wait 10 minutes to apply it. Apply it now. And if you are using a webhook, then you don't even have to wait that 1 minute, because the webhook will issue a Kubernetes event, source controller say, hey, this webhook is telling me there is a new commit on the Git, let me pull it. If there is a change, then it notifies the other controller, and the other controller will do the reconciliation. So okay. The difference between Flux and the toolkit is reacts to Kubernetes events. So it's also a reactive system, not only a pull-based system where it does things only at a strict interval.
Got it. Okay, so the get repository interval applies all the changes on that schedule, and then this interval on the customization is just really about fixing stuff if people modify it manually. So I'm assuming if something extremely bad happened to my cluster and I was making changes, I'd probably want to change that interval to be a bit more forgiving, I guess.
No. If you are dealing with an incident, you probably want to suspend this particular customization. And there is a command for that, is GOTK suspend customization and name of the customization. And what it does, like a Kubernetes cron job, it will never reconcile from that moment on. So you can do whatever you want on the cluster, fix it, then move your changes into Git, commit those changes, then resume the customization, and everything will be back to normal. But in the past, what people were doing were scaling to 0 Flux, so it will not fight with you. And the thing that we've improved here, maybe you have different things reconciling on your cluster. Maybe you have a customization for your apps and another customization for your databases. But if the incident is only affecting the apps deployments, then you shouldn't be stopping everything, your whole GitOps pipelines on the cluster. Maybe you want to stop that particular thing where the incident is happening. So we don't have to scale to 0 anymore, anything.
Okay, so can we just type that command here? Like if I run GOTK suspend customization, I'm just going to keep following the docs, assuming I know what I'm doing here. And the name of this resource is?
GOTK system is the name of the...
So that's no longer going to get any updates. That's
Yeah.
it. That's nice. Okay. Yeah. And I can just, I'm assuming, change this to resume. Awesome. Cool.
It tells you what revision it has applied. So it's the main branch and that particular commit.
Okay, so I feel like then we should deploy something to our system.
Yeah.
Good. So let's see. Now, what do you recommend? So I'm sure I've seen that it cloned something earlier, or did it clone it in the cluster? So I need to clone this repository. Okay, got it. Yeah. GitOps, and let's open this up. So would I add a new directory here?
Yeah, you can, from this moment on, you can organize however you want your repo. The toolkit is not opinionated in any way how you want to configure it. The idea is if you want to target your production cluster, in this case, all the definitions should be inside that directory. And you can use customized overlays, Helm releases, whatever you want.
Okay, let's start nice and simple then. And let's just do Nginx. Port 80. Now I'm not going to add a service or anything. Let's just I just want to apply this as it is, and then we'll see that roll out to the cluster, and then maybe make a small revision or something. So I would just do git add $1 million application, and then I just push this up to my cluster, up to GitHub, and we wait 1 minute.
Yeah, so we either wait 1 minute, or we can say GOTK source git, GOTK reconcile source git, and that's GOTK minus system.
Oh, I need to do it from this directory because that's where my kubeconfig is. GOTK reconcile source get GOT.
Reconcile.
Yeah, typing's not my strong suit, especially when I'm being watched. There we go. So this is now updated everything inside of the cluster. So if I run get pods, there we go. It's easy.
Okay. Now you can also do GOTK get customizations. And it will show you the same revision as the source. So it may happen that you push a change, that change gets pulled into the cluster, but it doesn't get applied. Maybe there is an error or some misconfiguration, and there will be a drift between what it's supposed to be on the cluster and what's really running on the cluster.
Right. Okay. So, okay. Right. I get it. Just thinking aloud here. What is so I guess this is going to come down to where your experience is really important here. Like, what is the best way for this directory to be set up? Like, what I feel now is that I've made a mistake storing my deployment Nginx inside of this production folder. I feel like, would you start immediately with customize so that you have bases and the ability to overlay into environments, or is this perfectly normal in a GitOps flow?
Well, nobody, I cannot say like use customize. Maybe you don't like it. Maybe you want to do Helm releases or other things. Maybe you want to generate all your YAMLs with JavaScript or Q or whatever and commit the final YAMLs to some other repo. But I think for most people, customize should work really great if you just want to do small changes of your deployments across your fleet. Customize has a downside in terms that you cannot just use variables. It doesn't do that, right? So if you want to set, for example, the region name, and the region name will be different between clusters, and that region name is somewhere in a config file or tucked down below, then you have to teach customize how to patch your things and so on. Maybe for that use case it's better to use a Helm chart and so on, but I really like customize. So yeah, use it if you can, but there are so many other options.
Okay, do you see a future for Flux 2 or GitOps Toolkit where there's like a controller for JSON, a controller for, a Carvel, maybe, all these other tools that do the same templating responsibilities as customized, but giving people a bit more flexibility or choice, etc.?
No, I don't think any of those tools are meant to be reconcilers. Those tools are meant to create YAML. So you should, if you want to use, let's say, Q or JQ or whatever, you can compile the final YAMLs in your CI, validate them with something like qval, apply policies verify them with conf test, for example. And after all these things are okay, then you should push the final YAML to a branch and let the toolkit reconcile that branch. I think the faster you see the YAML in Git, so you can do diffs and you can run this, let's say, offline validation, is better than running all these tools inside the cluster. And if the tool fails, then you have to crawl out logs and so on. I think it's better to get the final YAML earlier in your pipeline.
But that's not what Customize is doing, right? I mean, we are running Customize in the cluster to produce the final YAML. I mean, not in this example here, but that's what this controller does. Or have I completely missed the point here?
So, no. The Customize controller uses Customize as a library for many other things than just building a customization. For example, it does an ordering using Customize. For example, custom resource definitions before custom resources, namespaces before deployments, and stuff like that. It also underneath uses Customize to label all your objects inside the cluster. So if you want to say, hey, for this particular customization, what kind of objects have been created on the cluster, you can use a label with the customization name, and you'll get a list of all your things. So in a way, the Customize controller is using Customize as a library inside of it to deal with the reconciliation. Maybe the name is not good. Maybe it should be like sync controller or whatever. But yeah, I don't think you should create a controller for any templating solution you have out there.
Okay. Well, let's quickly bring in a couple of questions then, just I think that relate to this. And I think you've potentially answered a couple of them, but I'll pop them in anyway. So Ilya, I do see your first question. I'll keep that one till the end because I think that's interesting. But I will pop in this one. Ilya says, as a matter of personal preference, can I use it without customize? And I think the answer there is
yes, for sure. The controller can synchronize plain YAMLs. It's not opinionated in that way. It doesn't need a customization.yaml in your Git repo. It creates one on the fly and adds labels and all the things that it needs to do to enable garbage collection, ordering, and all this stuff.
Okay, and then he follows on with, could one build their own custom reconciler?
Of course. We intended for the toolkit to also be an SDK. So you can build your own controllers on top of the current API. And there is a development guide that we've published on the docs website on how you can build a controller with KubeBuilder that listens to source controller events, fetches the source that source controller has pulled from all these sources, and then it's up to you what you want to do with those manifests. It can be whatever. I've seen people trying to use source controller in CI systems where source controller pulls the source code from Git. Then there is a different controller that actually does the build of that particular source and pushes the a container image to a registry. So notification controller and source controller are not tied in any way to the GitOps idea, right? Like continuous deployment. You can do a bunch of other things with them if you want to.
Excellent. One more question and then we'll move on with the demo. So we have a question saying, can I use GitOps Toolkit with Subversion?
Not right now, but yeah, we've implemented S3 bucket support. I'm guessing SVN shouldn't be that hard if someone wants to do it.
I guess with the GitRepository being its own CRD, adding support for other code places, locations, whether it be Mercurial or Subversion, would just be a case of adding in the CRD and the controller to do the syncing aspect of it.
Yeah, in our case, you would add a custom resource definition to the source controller API. Let's call it SVN repository, and then you'll be adding a controller to a controller loop source controller that deals with that particular custom resource.
Excellent. Cool. Let's jump back over to our demo then. So what do you feel like the next step is here? Should we add a customized bases YAML or should we jump straight into Helm?
No, I would say let's show how you can add a different repository to your cluster. Like here in this example, we've added the deployment YAML directly to our fleet repo. But in normal cases, you don't want to do that. You want, let's say, if you are developing an application, probably somewhere in your app repo, there is a deployment directory or customized directory or something like that, where you specify how your app should be deployed. And the toolkit, what it tries to do it with these custom resources, it lets you add, register other sources inside the cluster and decide how they are reconciled. So let's add a different repository.
Okay, so I can copy this source and say I want to deploy my other app. And I do have a previous one here. So this is, I was messing around with the GitOps and I created some YAMLs rendered from Helm that provisions in FluxDB and Telegraph daemon set.
Okay,
so
let's go to the URL.
Yep. And then can I just use the public URL? Will that work just fine?
Yeah, so the Git repositories can have an SSH URL, and when you specify an SSH URL, you are obliged to define the an SSH key for it. If you use an HTTP address, if that particular repo is public, you don't have to configure any kind of authentication. So in this way, we let you add to your cluster things from open source, like, I don't know, if I'm having my own open source project, you can reconcile that particular thing without having to clone it or anything like that. If you trust me that I will do, I don't know, Semver releases and non-breaking changes, then you can actually add the upstream to your cluster directly. So yeah, you can delete the secret ref.
So is I think I'd like to clarify something there then. So if I use a public repository, in fact, no, if I'm using a private repository and specify a secret ref, and I remember coming across something in the documentation that talked about a read-only mode. So does that mean there's a write mode where the GitOps Toolkit modifies my Git repository?
Yeah, in the future, the GitOps Toolkit will contain two more controllers. One will scan container registries, and the other one, based on some policy that you define, will write back to your Git repo when you push new container images. Let's say you have your own app and you push Semver releases to your registry. Instead of going every time and changing the new version inside your YAMLs, you could configure the toolkit and say, every time there is a new Semver release in this particular range, on Docker Hub, for example, get that tag, write it back to Git, and some other part of the system, the customization controller, for example, will apply it.
Okay, got it. That makes sense. And I guess in read-only mode, would that semantic version and rules still be something that people can consume? Does it use state within a cluster to monitor those tags, or is that still something that's to be determined right now?
So in read-only mode, you can tell the toolkit to follow Semver releases for a whole repository. It doesn't look at container registries. So if you version your YAMLs and you do Semver releases, then the toolkit will be able to detect, oh, there is a new release on that particular repository, and you'll apply that release. But with the container registry, is more about writing back for each particular container.
Okay, got it. Right. So I'm assuming I do not want to override that. So we'll call this custom repo in line with the directory. With regards to interval, I mean, 1 minute seems like quite a sensible option. If I were to do 1 second, I mean, is that likely to cause problems?
Could be. I don't think it will actually work.
Right.
I think it will not work. It will set something like 10 seconds.
We can go over a minute and do that manual reconcile step. Okay. So if I save this.
No. Wait.
Oh, all right.
Let's see above if there is something else in this file. Oh no, it's only this. Okay, that should work. Okay, you can commit this one.
All right, so we're adding a second repository. Push this. And then we can do reconcile here just to speed it up. So I guess I'm going to assume if I do GOK system get repositories. I like it when things are just intuitive. Aha! So master main error here, I'm assuming. Yeah, this wouldn't have been updated. So is correct branch. Reconcile one more time, and there we go. That's now fetching the other Git repository, applying that to the cluster, so I can run Git pods. Don't see anything.
Yeah, you just declare the source. Now, what you should be doing with that source.
That's correct. See, I'm glad you're here. So I need to then tell it how to apply it. So let's.
Yeah, you
I'll
can
just.
paste it in the same YAML. Yeah.
Okay. So we want custom repo.
No, there you should say what you are actually trying to do here. In FluxDB, maybe it's a better name because you are applying in FluxDB. Okay, then the source ref should be your custom repo.
I wish I had named that better now, but I'm stuck with it.
So I've seen you had like two directories. Are those independent things or they have to be applied?
Yes. So there, I guess what you're suggesting there is I could have a customization to apply each of these individually, or I could just do a dot to apply everything recursively. Will both of those work?
Yeah, and you can also do dependency management for, let's say, for example, you don't want to install InfluxDB if Telegraph is not there, or the other way around. So you can, for example, define two customizations for each directory and say for the Telegraph one that depends on the InfluxDB one. And what the customized controller will do will build a dependency graph before it does the apply of your Git repo and applies the things in a particular order based on the dependency relationship between those.
Okay, that's pretty cool.
Yeah, why we've implemented that particular feature is because of admission webhooks and service meshes. I'll give you an example. If you install a service mesh, then you install your apps. Everything is good. When your app will be installed, if the service mesh is already there, it will get injected with the sidecar and it will function great. But GitOps is meant to work when you, let's say, bootstrap cluster from scratch. Let's say you lost your cluster or you want to build an identical cluster. Now, if you apply all the things in your Git repo in the same operation like Flux version 1 does, there is a great chance that your app pod will start before, let's say, the linkerd injector or the Istio injector. Right. And your app will have no sidecar and many problems from there because, well, it's not meshed and is meant to be meshed. With the toolkit, you can say, all my apps depend on this infrastructure customization that can contain Istio, linkerd, gatekeeper OPA, or any other stuff that needs to be there before applications get provisioned. And in using the dependency tree, you can reliably, clone clusters, create identical clusters, and it will happen in that particular order.
Okay, that makes sense. So just to make sure I understood that correctly, to use the dependencies, I need to define each of these separately, right?
Yeah.
Okay. And then I'm configuring the path here and changing the name.
Yes. And now inside
the... Yep, sorry, on you go.
Inside the spec, now you can add the depends on entry with O. Okay, depends on, and now it's name 2 point name.
The list of objects, yeah. Okay.
Yes, and it should be in FluxDB.
That's it.
Yeah.
Easy. I like it when things are this simple. Okay, so that looks okay to me. I'm sure there's probably a mistake, but
well,
yeah,
it should tell us. It should tell us everything that's going wrong.
Okay, so we're now going to apply InfluxDB and Telegraph with dependencies. We can reconcile. And I'm assuming I can run get customizations like we did earlier. Oh, we're in the correct namespace. Oh, we got it. Oh, so it's not ready yet. So we can see right away that it's not deployed the Telegraph daemon set because it's waiting on our InfluxDB containers to become healthy. It's currently pending. And there's Telegraph.
Yeah. One thing we should have done was to create a health check on InfluxDB. Like what we've done right now is we are configuring the toolkit to apply first InfluxDB, then Telegraph. But that doesn't mean that InfluxDB is actually running, right? You apply it, then it can take forever to spin up the pods. What we can do is add a health check entry to the customization and specify, hey, look for the deployment named, or in this case is a stateful set. Look for the stateful set InfluxDB and check it if that is healthy, and only then allow all the other depends on relationship to go for and reconcile. Going back to the service mesh example, you can apply Linkerd, but that doesn't mean that the injection webhook is up and healthy for your pods to be injected. So you can you can use health checks in this particular way to make sure that everything is running before nothing else. So.
Okay, so I do have an error, but that's my mistake because I haven't configured actually any PVC options on this cluster. So I'm just going to ignore InfluxDB for now. But to confirm what you were saying there, if my stateful set here had a oh no, it does have health hit. So how do I connect that up then?
So there is in the customization of the InfluxDB, you can add here a health check entry.
I can pull up the docs. It's GitOps Toolkit.
Okay, if you go to Toolkit Components, customize controller, customization, custom resource definition, and health assessment is on your right.
Yep.
Can you see there?
Cool. Oh yeah, so we tell the object that we are looking for to be healthy, the namespace and name. All right, got it. So, okay, so let's, I want to remove this. We have prune enabled. So I'm assuming if I just comment all of this out and push this up, it will prune them away. So I'm going to do that first. I like it when things go wrong because then I learn how to fix it. So remove InfluxDB and Telegraph. Do I get add? There we go. And because we have prune on, when I run the reconcile, it's going to remove those from. And if I run get pods. There we go. Terminating and InfluxDB is already gone.
You should also remove the, this is in the default namespace. Yeah, if you'd have had the namespace definition inside your, let's say, InfluxDB manifest, it will first, what it does, it goes through all the namespaced objects. So it will remove deployments, custom resources, and so on. After all of those are gone, then it will remove cluster level objects like namespaces, like cluster role bindings, and so on. Why we do this kind of garbage collection is for custom resources to be finalized. Otherwise, you could get into a stuck state where you delete a custom resource, it needs to be finalized by something, but you already deleted that something. So your namespaces and everything else will be stuck. So we try to play nice with with other controllers and do the deletion in different steps.
Okay, excellent. So, what's the best way for me to use this health checks? I'm going to bring Telegraph back in, but we don't have a satisfied dependency here.
Yeah, you can remove it, and you can add the health check for Telegraph itself.
Okay, so we're removing a dependency. And you want me to apply this as is? Sorry, I don't understand what you were suggesting.
I was suggesting to add the health check for the Telegraph daemon set, if you want to do that.
Oh, in fact, yeah. Okay, let's change this a little bit. So we already have this Nginx deployment here. So if I just add a health check to a liveness probe or a readiness probe to this, if I just copy them from here, then we can have telegraphs only get deployed if that is healthy. So let me add this. And we'll just do it there because Nginx will respond. Oh, it's going to respond by a. Oh, it'll be okay. This is why I shouldn't make this stuff up. Okay. Let's go into GitOps. What I'm going to do is add our production Nginx and deploy that first. Add probes to Nginx. And then we do a reconcile. And then if I run on this, we have our new Nginx spinning up and it should become healthy. I'll wait till I see 101. Yes, I didn't add those probes correctly. Let's see if I can quickly fix this or just move on. Oh, okay. No, it's not a named port. My bad. So let's add that one more time. Reuse my commit message, which I know I shouldn't do, but I'll do it for now. And let's get pods. Okay, it's now got a probe on it. So in order to demonstrate the health checks, let's come back to here, bring back our Telegraph DS. We can add our depends on name, and this is the customization
GOTK system.
Okay, thank you. We're also going to add a health check. In fact, I'll just copy this from the docs.
No. So let's think about it. You want to make the deployment depend on another object, right? Another thing in your infrastructure. So you'll be creating the health check on the customization that creates Nginx, right?
Yes.
Then you'll say, hey, all the things that I'm trying to add afterwards have to be reconciled only if that the GitOps GOTK system customization actually works, right? So the health check will go on the GOTK system customization file.
Okay, so the health checks cannot. They have to reference resources created within its own customization.
No. But you should, right?
Okay, so
you can define health checks in a customization that reference whatever in your infrastructure, even if it doesn't come from a Git repo. But the idea of a dependency is that you define all these checks on the object that creates them, and then all the other things will wait for that. Okay. If you define the health check on your daemon set there, what the customized controller will do will apply the thing, and then we'll check if it's healthy. What you want to do is do not apply the thing if if I don't know the health check is failing for another customization. Make sense?
Okay, so I got that completely wrong then. I thought the health check here was going to say don't deploy this customization unless this resource is healthy. But that's not what it's doing at all.
No.
Right. Sorry, I completely misunderstood that. Got it. That makes much more sense to me now. Whoops. Okay, so let's not bother with the health check on this. We're doing a health check, but for Telegraph, although there are no probes on it. So let's just take it out. Okay. So let's just apply this, and then we can move on. So add Telegraph again. So shall we take a look at the Helm controller, or is there anything that I've maybe missed here that you'd like to cover? Other than me just not understanding anything so far, but that's okay.
It's okay. It's a learning process because we added all these things that you can do, and I can understand how health check can be confusing. There are two roles to health checks. The role on the customization itself is you apply something and then you want to be notified if that particular something worked or not. That's one use case, right? Then when you create a dependency tree, all the dependents, if you have defined health checks on your customization, all the dependents will be blocked on those particular health checks. So, for example, you will not be deploying your app if the linker, the injector is failing because your app will not be injected. That's one example. Another example is don't apply any YAML if the gatekeeper deployment is failing because you want to ensure that everything that gets changed on your cluster is approved by your OPA policy agent, right? And for that to work, the policy agent has to run. So, yeah.
Okay, so I mean, I guess the only mistake I was really making there is this depends on is going to wait until this Nginx resource exists, and then I was going to add a health check here to check the health of this. But really, what you've just said there is what I should have done is add the health check here. Okay. So I had that wrong in my head twice. So really, if I had just added that we have a deployment called Nginx and the default namespace, then my Telegraph wouldn't have been deployed until this was actually healthy.
Yeah.
Okay. Makes sense. Got it. Finally. Okay. Let's take a look at the Helm integration then. So right now we have a GitOps pipeline that has two repositories, one managing the GitOps Toolkit system, one managing our $1 million application, which is nice and trivial. It's just some Telegraph stuff. If I then want to add something from Helm, like MariaDB, MongoDB, some sort of database, that Helm is the best way to deploy that. What are my first steps to doing that?
So first step, you have to define where is your chart, where is that particular Helm repository, right? And the same way you define a Git repo, you can define a Helm repo. And if you scroll down here, for example, here we add the Bitnami repository.
Okay, so we're using GOTK create source. We're telling it as Helm and not Git, and then we just specify the Bitnami repository.
Yeah, which is public. If you have a Helm repository that's private, you can also give here in the command the username and password or token of your repository.
Okay, so if I go into my GitHub directory here, we were feeling brave. So production, we were brave. I was feeling brave. This is now production. And then we deploy this. That's going to create. Bitnami. We've got a kind Helm repository called Bitnami with this chart. And then Okay, so this is just generating the YAML to create a namespace.
Yeah, so one particularity of our Helm controller is the fact that Helm controller only installs charts. It doesn't create anything beside what's in the Helm chart package. And you shouldn't be placing namespaces, for example, in your charts. So this is where Helm controller, customized controller work great together with the customized controller. The customized controller will create namespace definitions, which should be in your fleet repo or your cluster repo, and then we'll apply Helm release manifest, and those you can tell those, hey, I want this particular Helm chart to be installed in that particular namespace.
Okay, so let's grab this and then generate this. And in fact, what I'll do is just next to this, v1 kind namespace, rather than just doing the command contour. And then this function. So we're using semantic version in here to deploy a version 2 version v2 contour. You tell it the Helm repository name, which we just created. We give it a release name, the target namespace, which I just added to the YAML.
And after export, you should be creating the contour YAML, not pipe it in.
Yep.
So
we should have this here. Perfect. So my first question here is, how do I customize the chart with values?
So here you can type values.
As part of the spec?
Yes. That's the chart spec. No, part of the Helm release spec.
Okay. Is this just an object where I can say my value 1, 2, 3, 4?
Yeah. So
right.
These are those values specified here will override the values.yaml from your Helm chart, and you can do other things like I want values to be fetched from a Kubernetes secret. Let's say some charts, you have to pass in, I don't know, username, passwords, tokens, and so on. You don't want to place your tokens, your secrets here in plain text in your Git repo. So you can use something like Mozilla SOAPs or seal secrets to manage Kubernetes secrets in a GitOps way. And then here in values, instead of saying value token something, you'll say values from this particular secret. And what Helm controller will do will take the secret from that lives inside your cluster and will merge the values in your secret with the values you specify here. So here you should only set values that are not secrets. All right.
Not secrets. Okay. That I definitely understand. Modifying the values is quite easy. So I can just add all of this and added contour via Helm and push. And if we run our reconcile one more time, see. Oh, there our namespace is 10 seconds old, so maybe I was just a bit quick. There we go. We now have contour running deployed via Helm via the CRD in GitOps Toolkit.
Yeah, it will create many other pods. Right now, it's just it spins up the third generation, and then it'll spin up an Envoy daemon set and the contour pods, which are the control plane of the ingress controller. But yeah, and with Helm, you can do several things. For example, here, what we are doing is using delegation. If you go back, for example, to the Helm release definition, you'll see that there is a target namespace there. So what I'm doing here, I'm placing the Helm release definition in my system namespace, GOTK system. Let's say no one has access except for cluster admins to that particular namespace. And I want to provision some infrastructure for a particular team. And I can use target namespace to say, hey, I'm declaring the Helm release here because I don't want anyone else to be able to modify, but cluster admins. I don't want installed in the same namespace where the Helm release is defined. I want to install it in that particular namespace. And this gives cluster admins the power to provision things in other teams' namespaces or tenants' namespaces. And yeah, no one can modify that original object.
All right, excellent. Let's jump back over here. So we've covered Helm. And this was just another Git example.
We have an add-on for the GitOps Toolkit that's composed of Prometheus and Grafana, and we have instrumented the controller, so have an overview of what's happening on the cluster, and here is how you can deploy the monitoring stack. We are currently developing more, adding more metrics to our controller. So in the next release, you'll be able to set up, for example, alert manager, say, hey, when a reconciliation fails, send me an alert based on some metric that I don't know, customized controller is failing to reconcile in FluxDB in the last half hour or something like that. We have the notification controller, which funnels all these alerts to Slack, Microsoft Teams, and so on. But Alert Manager has so many backends that knows how to deal with them. I don't know, PagerDuty, and there are lots of it. And we don't think notification control is the only answer to alerting. So that's why we are going to add metrics. So you can use Prometheus and Alert Manager to do things like that, and also build nice dashboards so you can see all the customization with their status, how long does it take to do a reconciliation, and if it failed or not, and so on. This is, let's say, our Grafana dashboard collection that will be shipping, and maybe in the future we'll have a full-blown user interface. But for now, we try to have like top-notch Grafana dashboards so you can see what's going on.
Oh, very cool. Well, I will add this. I think these steps here are fantastic for kind of covering everything that we've already been through today, so people can follow along with this in their own time and deploy their own GitOps toolkit. What I will do is, is there anything else you want to demo before I stop sharing my screen, or do you think we've covered most of the things that you wanted to go over?
Yeah, I think we've covered the basics. The idea is that with the toolkit compared to Flux V1, we let you define your cluster state from multiple sources, and then you decide how those sources are going to be reconciled. If you want to add health checks, if you want to add garbage collection, if you want to suspend or resume them, depending on if you have an incident or not. All these things come from feature requests and things that we've seen for Flux V1, how our users wanted more stuff, and yeah, we added them to the toolkit.
Yeah, I think it's a very powerful set of tools. I'm really impressed with just how quickly and easy it was for us, to bootstrap the system, start adding our own Git sources, and then applying it to the cluster. And the Helm integration there was so trivial. Really, really impressive. Just the ergonomics of working with GitOps is nice. I really like it.
Yeah, for Helm, we have many other things that you can configure in that particular Helm release. For example, you can trigger Helm tests after a chart is installed or upgraded, and based on the result of the test, you can roll back to the previous version. Let's say you are running on 1.0.0, you bump it to 2.0.0, it fails, the Helm test failed, or the native Helm health check fails, like the deployment is stuck or a stateful state is stuck. You can tell Helm controller, if that one fails, roll it back and let me know. So you end up with the previous state that should be fine, and you get a notification, hey, your Helm test failed. This is why it failed, and we roll it back for you. And that's one feature of Helm controller that we've added recently.
Oh, very cool. So we have one more question that we skipped over earlier, but I think now would be a good time to cover it, and then we can maybe talk about what's coming down the line, and then I'll let you get back to your day. But Ilya left a question earlier, and he was asking about Rancher's new product called Fleet and how that really compares to GitOps Toolkit. His specific question is, Fleet seems to be designed for scale, and how does that compare to what GitOps Toolkit is doing? Is it meant for a very specific use case?
We are working on integrating the toolkit with cluster API. So our approach is a little bit different from what Rancher and OpenShift and others are doing. Instead of managing everything from the management cluster and make that management cluster a single point of failure, what we are trying to do is, when you bootstrap clusters, you'll be adding cluster definitions in your Git. You install the GitOps Toolkit on your management cluster. Then the toolkit will discover that, okay, a new cluster has been created, and the toolkit will be able to provision itself on that particular cluster with the repo that you assign to it. And then even if the management cluster goes down, runs into trouble, all these clusters will be able to keep working, keep synchronizing with their own Git repos. And in a way, our GitOps approach is more distributed than having everything on a management cluster and drive all the operations from a single point. But you'll also be able to do that with the toolkit if you want to. Customized controller has a feature where it can mount an existing kubeconfig from a secret. So, for example, many copy providers will create a kubeconfig for each cluster they have created, and you can tell Customize, hey, reconcile this source, but not locally. Use this particular kubeconfig, and it will connect to that cluster and do its job. So we are trying to cover both things, where from the management cluster you apply everything, or from the management cluster you bootstrap your clusters, and then they can run on their own with no single point of failure. So yeah, I think our approach is very different from what Rancher is doing.
Yeah, and very exciting to me. I'm really enjoying my exploration with the cluster API right now and with GitOps Toolkit. And now you're pushing both of these together and giving me this workflow that will allow me to have GitOps Toolkit on my management cluster, bootstrap itself, and then go into its own reconciliation loop, which is really exciting. I'm looking forward to playing with that new feature.
Yeah, I think another use case is for installing the cluster add-ons after you bootstrap a cluster. So you can have like a generic Git repo with all your cluster add-ons there, right? And you can tell the toolkit, hey, after you create a cluster and you see that the kubeconfig was created, it works, you can connect to it, install these add-ons from this repo at this particular revision. And you can sample your cluster add-ons, make releases out of it, and the toolkit will keep updating your fleet based on that. So the idea of a multi-repository gives you this freedom of saying, I want a dedicated repo with only cluster add-ons, and maybe other repos with, other things like user applications and stuff like that.
Awesome. I look forward to that update coming down the line. So I just want to say thank you for spending the last hour and 15 minutes walking us through GitOps Toolkit. Like I said, it's just really impressive how easy it was to get started and start deploying things to our cluster. So thank you for your continued work on this. It's really cool to see it.
Thank you very much, David, for inviting me. And yeah, I hope by next year we'll do another round, and it will be like full-blown KP support.
Next year, I'm going to schedule you in every month to follow the updates. I think I'll just keep harassing your calendar until you finally give in and say yes. But all right, well, thank you again for joining me. It's been a pleasure. The video will be available online. All of the show notes will be available in roughly an hour. And thanks again, and I'll speak to you all soon. Have a good day, Stefan.
Bye.